To share with you some of my experiences and also one of my favorite features about Postgres, which is logging actually. So basically, the typical scenario that we run into is a customer or someone who wants to use Postgres. They want to get started. They're tired of MySQL. They're tired of SQLite, and they want to get up and running with Postgres as soon as possible. And they want it to work fast. They want it to serve up their thousands of users and whatnot. So the checklist that we typically have is, you get this on Google. So you have to set listen addresses to star to make sure that you can get TCP/IP connections. You want to make sure that your port is set correctly, depending on whatever your needs are. It's not 3306 and it's not 1512. You set your shared buffers so that the database can actually use a good amount of the system's memory to do whatever it needs to do. And then you set work mem so that you can do your sorting and merging and all that good stuff in your queries without crashing the database and without being very slow. Next item on the list is to set your autovacuum costs so that you're not vacuuming very slowly or infrequently, which would lead to some other performance issues. And then finally, you want to set your random page cost because you got some nice SSDs and a big 20 bay array and all that kind of stuff, right? So you want to set your random page cost so that your indexes are used. Okay? So we're all good to go, right? No, not yet. Don't forget, you need to do logging. Okay, you have to tweak the logging parameters. The thing about Postgres is the way that we ship it is that we ship it with the parameters default set pretty conservatively so that anybody can use it, even a developer on an old laptop. So sometimes things like shared buffers need to be tuned up, all the costs need to be tuned, logging needs to be tuned as well. And if you don't do that, what are the consequences? If you don't log properly, it will slow down diagnosis and recovery when there's an outage or performance problem. So you wake up at 3 a.m. and your website's down, you got a like notification from PagerDuty and all that kind of stuff, and you're trying to figure out what's going on. And without logging properly, you're going to take more time to get to the root cause. And because of that, it reflects poorly on your boss, on you when your boss asks you what happened last night at 3 a.m. when the database went down. You say, I don't know, I just restarted the database and then everything worked fine. And yeah, that's great, but I think professionally speaking, that's not a good answer. Another consequence is that it prevents you from planning for the future. If you don't know that you have impending doom, you don't know that you need to buy new hardware. So having logging and stuff to look back on will allow you to properly gauge how much hardware you need to get and when you need to get it. Now, Postgres logging is actually very, very useful if you haven't used it before. It can tell you a lot of things. I'm just going to go through a relatively short list. So just to go right through it. So what it can tell can tell you when a query started, finished, and how long it took. It can tell you some indicators that your database might be corrupted, like missing magic number XYZ, couldn't find this page, whatever. So that's not a good thing. So it'll tell you if you might be corrupted. It'll tell you any errors with the query or with the connection attempt, so like syntax errors and stuff like that, missing table names. Statistics about queries and maintenance activity, so if there's an autovacuum going, if you have auto explain on, you can actually find out how much of your query is actually using cache, how much of it is seeking from disk, stuff like that. It can tell you information about temp files. So if you're spilling to disk and you have high I/O on your system, and you see temp files being logged, you know that something's wrong with your sorts. It can also tell you who connected to the database, where the connection came from, and what queries ran before a transaction was rolled back. That's actually very useful. Sometimes what you can gather from a log is what's the last query that ran, and that's the one that caused the problems, but you don't know what led up to it. If you tune Postgres properly, you can actually get that information. And there's so much more that you can get out of logging. So my principle is log as much as you can for as long as you can. And why? Because more log means faster time to diagnosis, faster time to recovery, and when you're recovered, all your users are going to be happy. And when all your users are happy, you can go to bed again and get a nice restful sleep. And then the next morning, or the next week or two, you can actually look back at your logs and audit and plan for the future. So in short, log equals better for your business, faster time to recovery, and it makes you look good. So what do we need to do to make sure Postgres is logging well? Well, there's actually a lot of things that you can do. And here's actually a list of all the logging parameters there are. There's 26 of them. So there's a lot of things you can do, and it's kind of a daunting list to go through. And some of it you may want to just turn on, and because the defaults are off. But one of them, I think the starting point, what I would recommend is to focus on this one particular parameter, which is called logline prefix. And what logline prefix is, if you're familiar with printf, which I think most of you are, it's a printf style string that goes to the beginning of each line. And as of version 10, so all the more modern versions, it defaults to M and P, which is basically a timestamp with milliseconds and the backend PID. So every line that gets logged, you're going to get a timestamp and you're going to get a backend PID. That's good, but that's not as best as it can get. Now, if you're using 9.6 or earlier, you're out of luck because the default is blank. So you better change this parameter if you haven't already. Right? Now, Postgres will provide several different escapes. So M and P are just two of them. There's actually a bunch more, which I got a screenshot from our documentation online. So you can use any of these to put in front of your line, and that'll help you with sorting and figuring out where your problematic queries came from. The more you log, the more chances you have to actually catch the culprit. So I would recommend to, there's some of them I don't really find very useful, but I think about half of these are ones that I recommend using. Now the reason why I actually got inspired to do this talk was because I ran into several of our customers who did not have logline prefix set. So in preparation for this talk, I actually dug through a couple years of history of our support tickets, and I found out of 130 conf files, 5% of our users don't change logline prefix. So 5% either have just the timestamp and PID, or they just have nothing at all, which is kind of surprising to me. 38% only log timestamps. Now, you might wonder, okay, if the default is a timestamp and a PID, why are some people doing only timestamps? Well, that's because Enterprise DB, we ship our own version of Oracle-compatible Postgres, and we set that default as just a timestamp. So if 38 people are using only timestamps, that means 38% of those people are not even changing logline prefix anyway. So this number, I'm guessing somewhere around half of the people don't even touch logline prefix. And why? I kind of wondered why. I don't know. I don't really have an answer. It could just be negligence. They might just think, oh, whatever. Logging is not that important. It could be that they're just like intimidated. Like, oh, I don't know. I don't want to deal with logging. I don't like looking through logs. It makes me fall asleep. I don't know. Maybe that's why. And if it is why they're just kind of intimidated, I can understand, I can empathize, because in my career as a DBA, I had to look at pages and pages of text, and this is why I titled it "The Wall of Text." It's just lots of text, and you don't know what to do with it. One second, let me see if I can share this now. No, okay, all right, whatever. All right, we'll just live with this. If you can't read this, it's a bunch of update, insert, begin, end statements. It just says log, statement, and then a query. And then there's like a few errors here about some relation that doesn't exist. And okay, so the problem here is the relation pgbadger accounts doesn't exist. Okay, so that means the table got dropped or something like that. Oh, hey, I see it. There it says drop table pgbadger accounts. All right. But then that's all I know, right? All I know is that somewhere somebody did this, and I don't know when that happened, who did that, whether it was an app or if it was some malicious, like a user, like a human or something like that, right? So this is with nothing, no logline prefix. Now let me add the 10 and up default, okay? So now I've got a timestamp and I've got a PID, and then the rest of the message. Okay, that's a little bit better. So now I know that the drop table happened at 11:15 a.m., but then everything else happened at 11:15 a.m. too. So can't really do much there. But hey, I have a PID. I can sort. So I'm going to sort on the fourth column. 1, 2, 3, 4. Okay, fourth column, PID. Okay, here we go. I've sorted it. Okay. And since it's hard for you guys to read, I'm going to color code it. So the bottom one, okay, here we go. This is still hard to read. Okay, let me just read it off for you. 11:15 a.m., process 658. This is the only thing that it did. Somebody logged in and it issued, that person dropped the table. Okay. All right, so what do I tell my boss? Somebody dropped it, I don't know, right? Okay, so I think we need to add more to this line, right? Okay, so let me share with you some of my personal favorites. Okay, so you should add the application name. Okay, the application name will actually tell you if it was like a JDBC driver. It would be, it might even be the autovacuum agent. It could be wall replay. Probably not in this situation, but it'll tell you all that kind of stuff. The username, what user that person logged in as, okay, and then the database name. So if I have I've got a customer with a multi-tenant setup. We got 100 different databases. Now, if I'm concerned about this drop table statement on this one particular table, I don't need to look at all the lines. So I can filter out by the database name. Okay, this one's the most important one to me. This is the remote host IP with a TCP port. Okay, that's very useful, I think. Okay, so definitely have that in your line. Process ID, standard for most people. Session or process log line, so you have a process ID, and then and you can actually add on the order in which those queries came in for that session. Because if you're sorting, you might end up sorting on the query and mess up the actual timestamps or the lines that show up. Okay. You can actually also sort based on a transaction ID too. That's very useful as well sometimes. Okay, and another pointer on the R. This is actually very useful. The port part is pretty useful if you're using pgbouncer. It helps you map a particular session in the database to a particular user that's using pgbouncer. Okay. So that's the logline prefix section. Now I want to also turn on a few other parameters. So there's 26 of them, right? I don't think you need to turn on all of them all at once. At least these ones, okay? Log min duration statement, it'll actually help you log the poorly performing queries. Log statement, if log min duration statement is not useful enough to you, maybe log statement might, but that logs everything. So you might want to make a mix of log statement and min duration statement. I'll go through that a little bit more later. Log connections and log disconnections. So when a connection is attempted, that gets logged. So-and-so from server X1234 attempted to log into the database, and subsequent to that will be like it was authorized or it was denied. Okay. Log rotation age, log rotation size. For those of you who have really chatty log files or applications, you might want to rotate based on your age or your size. Log auto vacuum min duration. That's actually very useful if you've got strange auto vacuum behavior going on. So having that, it prints out some statistics of what it vacuumed, how many pages were reclaimed, and stuff like that. Log checkpoints. That's useful too. If you have I/O spikes and you're wondering why you're having I/O spikes, and you turn on log checkpoints and you realize the checkpoints line up with the I/O spikes, well, there you go. It's because of your checkpoints. Okay. Log temp files. This will help you identify any workmem issues that you didn't allocate workmem enough or something like that. Okay. So let's say I turned all this on. I set my logline prefix to what I like. So now I try again, and okay. So now I've got this line. Now where is this thing? Sorry, I'm having trouble with the two. Here it is. Drop table of pgbadger accounts. Okay. Now just before it says connection received from localhost 127.0.0.1. Okay, that's kind of strange. I didn't do it. I didn't log in and drop the table. So, okay, but at least it's showing you connection received, connection authorized, and so on, right? So you can actually make a little bit more sense out of it. Okay. So now let's try it with all of my favorite parameters. Okay. Whoa, this is really big. Okay. All right. Well, at least now you can see timestamp, PID, logline, transaction ID, user, database, application, and then IP address. Okay, now we're getting somewhere. Okay, now let me sort this again. Okay, I'm going to sort this by PID. Okay, and obviously you guys can't read that because it's too small. And so I'm going to highlight this. You guys can't read that either because it's too small. But let me just read it off for you. Okay, so basically this time around I've got a user named Postgres logging into my database using app PSQL. So someone got a PSQL shell. And this person logged in from IP address 172.1703. Okay, so now I can go to my network admin and say, hey, what server is this? Who attempted to log into that one? And basically, you can actually find your culprit that way. Okay? So you can see logline prefix is very useful. It helps you track down bad queries, slow queries, bad users, and so on. Okay. Now, as you saw just now, I mean, this is a lot of stuff, right? And this is just one screen full of it, and you've got maybe a whole day's worth of stuff to go through. How much is too much, right? Well, one of the concerns is, well, what if I run out of disk space, right? Or what if I create too much I/O just by logging? Well, okay, once again, my mantra is log as much as you can, as long as you can, as much as your system can handle. Okay. Now the nice thing about Postgres is that you turn them all on. It doesn't mean that you're stuck with them, because most of those items you can turn off with a HUP. Okay. So if you find that you got too much stuff going on, you can actually slowly turn stuff off based on what you don't need, and then get to a comfortable spot. Okay. Another idea is, most of you guys have probably heard the mantra, pgxlog should be on a separate partition, right? Well, why not put your logging on a separate partition too? Right? So if you got your wall files on a partition and you've got your log files on a separate partition, then your queries and your actual data doesn't get impacted so much. Okay. For those of you who are still kind of intimidated by the walls of text, if you're not already, get familiar with grep, awk, and sed. Those are your friends. They will actually help you pull all the necessary information out of the log so that you can analyze it. Another idea is to compress your log files using a cron job, so that way you don't run out of disk, because a filled disk will stop the database, so you will crash. Yeah, so compress them and store them off somewhere wherever you need to. So basically, if my thinking is that if you know what to look for, you can filter out all the noise that you need, that you don't want, and just focus on what you actually need. Okay. Now, speaking of verbosity, you can actually tune how much Postgres logs based on this parameter called log min messages. The default is warning. This is in order of escalation. Okay, so if you actually set log min messages to panic, you will not get anything, and you'll only get panic messages, which is not very useful. So warning is a default. Notice and info sometimes are useful, but you'd only need to go there if someone actually, if you really like scraping the bottom of the barrel for some information. And debug, if you're not a developer, if you're not a Postgres developer, don't even bother touching that. I don't think that generally doesn't help much for DBAs and sysadmins. Okay. Now I'm going to walk through some of these values for real quick. So warning, you'll occasionally see warnings in your log, and that's not necessarily a bad thing. It's just Postgres being kind and proactively telling you, hey, watch out for this. This might need to be addressed soon. Okay. If you see the word error, that sounds pretty bad, but what it really means is that it failed to execute a command. So like there was a syntax error, there was a typo, but sometimes it could be related to replication. Okay, so it could be a bad thing, it could not be a bad thing. So read it and understand it. A fatal message, that is sometimes actually not as bad as it sounds. If you actually send a wrong password, or if you're trying to connect to a read-only database, you're going to get a fatal. Because fatal basically means we're going to cut the connection because some kind of problem happened. And usually that problem is, oh, my Ethernet cable got unplugged or something like that, right? So fatal is a session termination. Error is a query termination or a statement termination. Panic, however, this is the one that's something that you got to really pay attention to. This one is usually because of some kind of system problem. So like a seg fault or some other underlying bug that Postgres encountered. And what that will do is the one session that caused the panic will be terminated, and so will all the other ones. So the entire database comes down. And the reason why is because Postgres does not want to corrupt the shared memory. Okay? So these are the ones that you want to pay attention to. If you got a monitoring system like Zabbix or Datadog or something, you might want to, track these. Like, hey, how many errors am I getting a minute? And if it's a spike, then you might want to go investigate and figure out what's going on there. Okay? Okay. So info, which is not listed here, it provides information that is implicitly requested. So like, let's say I do a vacuum verbose, I will get the verbose output in my PSQL shell, but it will not go into the log unless I set log min messages to info. Okay, so stuff like that. Some of that extra information that's useful to me as a user at that time, it won't get logged to the log unless it's set to info. Okay, so I think for the remainder of this talk, I'm going to go through some pointers on what to look for as a DBA or a sysadmin. Okay, so some common issues. Some tips. So don't ignore detail and hint messages. They're actually very useful. And you think this is kind of obvious, but I've encountered so many customers. They're like, hey, I got this error and I don't know how to deal with it. And then here's the output, and he shows it to me, and I said, well, the detail and the hint says do this. Have you tried it? Oh, no, I haven't. Okay, why don't you try it? Okay, I'll show you an example in a second. Okay, a spike in fatal messages. That in my experience, that has often been correlated to misconfigured applications. So like some DevOps guy decided to push a configuration and he forgot to change the password back to the production password. You're still using the testing password, right? So then if you see a spike there, users are wondering what's going on and you're getting notified. Go talk to your DevOps guy and say, hey, you guys changed your configuration recently? Okay. A spike in error messages could be a development, like an application bug. So I've got some situations where some developers, they push some code and the release engineer pushed it out to their servers and all these errors started coming through, and it's because they replaced the L with a 1 for a table name or something like that, right? So if you're monitoring for this, you can actually find application bugs. A spike in error messages could also indicate broken replications. So read your error message, find out what it means, and deal with it accordingly. Okay, if you've got auto-vacuum problems, you're wondering why your table is bloated and all your vacuums, your manual vacuums and your auto-vacuums don't shrink the table, you can go look for long-running transactions in pgstat activity. Okay, so just I'm going to go through some examples of these. So and then some other ones, as long as we have enough time. Okay, so the hints, right? So like I was saying earlier, right? You want to read your hints. Okay, so here I got a warning. It says database Postgres must be vacuumed within 9,700,603,669 transactions. And actually, if you look at it, it's decreasing one at a time, right? So it's like a ticking time bomb. And my customer might come to me and say, hey, Richard, what do I do? I'm getting this warning. I don't know how to deal with it. I say, well, why don't you read the hint? It says, to avoid a database shutdown, execute a database-wide vacuum in that database. You might also need to commit or roll back all prepared transactions. So then I say, okay, let's log into your database and run a vacuum. And 10 minutes later, everything's great. The warning's gone, right? In case you're wondering what this is a wraparound warning. So it's outside of the scope of this talk, but basically the way that the pages and tuples are organized in Postgres, each tuple gets a transaction ID, and we only have 4 billion of them. So if you have, after time, you're gonna run out of transaction IDs to work with. So you do have to vacuum, even though you're not doing updates and deletes. Okay. Another thing, so the application configuration issues. So this thing got this wall full of, a screen full of fatal. Database system is starting up. So what does that mean? Like, it sounds kind of bad because like, oh my gosh, I'm getting all these fatal messages. What this really turned out to be was that configuration problem. This guy had his applications continuing to run even though the database was down. This was because there was some kind of issue with the database itself. So as the database is trying to recover itself by replaying wall files to get to the latest checkpoint, or from the latest checkpoint, the application kept trying to connect. So if you look at the timestamps here, every second is trying to connect. And as a database, as a DBA, it looks bad, but actually it's not. It's just because some guy out there didn't shut down his application. And it actually makes it harder to diagnose. So what I would do is I would talk to the guy and say, hey, can you shut down your application? And then that way I can actually focus on log and panic. Okay? All right. Application bugs. Okay, so I mentioned the typo one. Here's another one. Warning, there is no transaction in progress. And unexpected EOF on client connection. Okay, is that bad? I don't know. Oh yeah, these other examples, like there's no like IP address. Like how many, is this a bunch of different servers? It's actually just one. You know, if you had the %R, you would actually know. So this one, you know, what what is the statement? What is going on here? I have no idea. So what this turned out to be was, okay. What this turned out to be was they had a bug in their code. They were doing an unconditional rollback. So I did begin, I did insert, and then I did commit, and then I did rollback. And then it would tell me, oh, there's no transaction in progress, right? And so as a DBA, I'm like, okay, this doesn't look good, but I'm going to go back to my developers and say, hey, are you guys, double rollbacking or double committing or something like that? And then sure enough, that's the problem, okay? Errors relating to broken replication. Okay, so requested wall segment blah has already been removed. If your replication is lagging, and if you check in your logs and you see this issue, this is probably because you built up enough of a lag that when it tried to replay some files, the wall keep segments was too low and Postgres already removed them. So then you're kind of stuck. Either you got to fish it out of your primary or out of an archive somewhere, and if you can't, then you basically have to rebuild your replication. Okay? You've experienced that before.
Temp is totally fine if you actually have a restore command.
Yeah. Yeah. So if you see this, you might need to increase wall keep segments or use replication slots. Okay. Auto vacuum and bloat issues. Okay. So if you turn on log min vacuum log auto vacuum min duration, if you turn on log auto vacuum min duration, you'll get this kind of output when auto vacuum runs. And in this particular situation, it says tuples. 198 removed, okay. 125,983 remain. 99,000 are dead but not yet removable. Okay, so, okay. If this keeps happening and that number keeps increasing or doesn't change, and you're wondering why your table is bloated, it's probably because there's an idle transaction somewhere, right? And then you go look in pgstat activity, look for idle in transaction, and sure enough, something's probably been open for like a month or two, and you just got to close it. Okay. Temp files. So if you get this message, temporary file was created, and the size here was 8 megabytes, 11 megabytes, 13 megabytes, 10 megabytes. So you're getting, for one query, 5 temp files, each of them somewhere between 8 and 13 megabytes. You can see how this could cause an I/O spike pretty easily. The reason for this is because work mem was too low. So increase your work mem so that you can sort in memory instead of on disk. Okay? All right, and then finally, locking and blocking. Okay. Oh no. Oh, I have 5 minutes. Okay, good. It just said red. I was like, oh my gosh, I got to stop. Okay. So in this situation, sometimes you've got some long queries, like some updates that take a long time, and you've got some other things that are trying to subsequently either access or update the same tuples. You're going to see this message saying, process whatever is still waiting for this kind of lock, and you can see actually there's a wait queue. Several other processes are doing that. So if you've got some, if your customers are, complaining about things being slow, it could be because there's a really bad query that's performing very, very poorly, and it's only going, it's finishing every few seconds or so, and everyone else is waiting as that one is trying to finish. Or you could have a deadlock situation where that's a coding error. So if you see deadlocks, talk to your developers, try to find out where they're deadlocking, race condition. Sometimes it's because you got two, big company, 2 separate projects going on, accessing the same tables, and they're doing it in a different way. So you as a DBA can be the mediator for them and tell them how to fix it. Okay. So finally, with lots of logs, it could be kind of hard to go through. So my recommendation is to use pgbadger. This nice Perl script will digest all your logs for you, put it into an HTML file, and you can actually get stuff like graphs, statistics. This particular query ran the slowest out of all your other queries, right? And this helps you. It helps with capacity management as well. Okay. Other people, some people don't like pgbadger. So other options are to use pganalyze, but that's a paid service. Or you can actually log to CSV and then ingest your CSV log into a Postgres table and create your own queries to process or analyze your log stuff that way. So that's a DIY option. I don't really recommend it unless you really know what you're doing. Okay, a couple more things. Oh wow. Okay, my technical difficulties actually slowed me down quite a bit. Okay, the auto explain. Turn this on if you want to add explain output to your log. So that way, when a query is slow, you actually get the output in your log, rather than having to manually try to reproduce the situation yourself. This adds extra I/O, so you will need to strategically turn it on, when you need to. PG statements, not a logging feature, but it is another way to get statistics on your logs, find out the performance, and know how to improve your system. Okay. Okay, so some gotchas. If you guys need to head out, that's fine. I can go through this with the people who are interested. So logging collector, if you are using syslog and you have turned off logging collector, and then you need to switch back to stdr or log to like separate files, you need to make sure logging collector is on. I've seen some situations where people forgot to turn it back on, and then they're like, I turned on. I'm logging stuff, but I don't see it. I can't find anything. It's probably because logging collector is turned off. Okay. Log file name. This is kind of like logline prefix. It's got a bunch of these %printf style escapes, and if you do not have the relevant escape in your file name, your logs will not rotate. So, like, let's say you want to log every hour. If your file name does not contain a timestamp, it will not rotate. It will just append to the one that it wants to append to. Okay. Log min duration statement versus log duration. Log duration will log the time that it took the query to run. It will not log the statement. Log min duration statement will log the time and the statement, but only the ones above the threshold that you set. Okay. Now, where this is useful is if you've got a high traffic workload, you don't want to log all your statements. That generates high I/O. So you turn on log duration. You get all the durations, then you can throw it into your statistics manager or calculations and figure out and look for anomalies that way. Okay. Log min duration statement versus log statement. Now this one, log min duration statement. So duration and statement after a certain threshold, it does not log parameters. So like let's say you're using prepared statements, it will not log the parameters that are passed into those statements. Okay, log statement will log the parameters for you too. So if you're wondering, man, this query errored out, I don't know why. If you had log statement, it'll tell you what parameters were passed in, and that way you can figure out if it was a syntax error or some kind of type error. The other advantage to log statement is that it logs a statement before the query is executed. This is useful because let's say my query actually crashed the database. Now, with log min duration statement, I will never know what that query was because the query only gets logged when the query is finished. But with log statement, the query is logged before. So if you get a statement logged and then you see a crash, that's the statement that crashed the database. Okay? So, quick summary, turn on logline prefix, turn on your log connections, log as much as you can for as long as you can, and run your logs through something like pgbadger for visibility and forecasting, and monitor your spikes in fatal and error and warning messages to go back to your developers and sysadmins or colleagues. Okay? I don't think we have time for questions, so sorry. I'll be around if you guys have questions for me. So thank you.